All right, and now the last step that you had to do was to figure out what to replace here in this feature scaling implementation. Well, here that's super easy. We simply want to, feature scale all the features. We want to scale all the features. We want to scale age and salary. And of course, we don't have to scale the dependent variable purchased because its values are 0 and 1 and therefore are already in the range of values we want. So all good with this. So basically, we're only going to scale these two features, age and estimated salary. And therefore, here what we just had to do, as a replacement, was just to remove that selection of the indexes here. Here we selected all the indexes starting from 3, but this time we don't have to do anything. We can just scale the whole matrix of features. So I'm just removing here the index selections, and there you go, we'll be ready to feature scale both our training set and our test set. And I remind that this is absolutely compulsory to do this after splitting the dataset into the training set and test set in order to avoid information leakage from the test set. All right, so there you go, my friends. That was what you needed to do for data preprocessing. Congratulations if you got the same thing. Don't worry about that test size. This is just for the form, but there you go. This was simply what you had to do. All right, so now we're gonna do a few prints to actually see the before and after feature scaling. So what I'm gonna do is right after this code cell splitting the dataset into the training set and test set, I'm going to make 4 prints just to show you. If you don't need to look at that, well, feel free not to include these new code cells. But what I want to do is print first x train, then I would like to print y train. So here, y train. Then next one, I would like to print x test. And finally, I would like to print, well, y test. Okay? So that, and after feature scaling, however, we will just, print 2 cells because we actually don't apply feature scaling to y, and therefore we'll just print first, well, x train again, and second x test, right? Because these will be the only sets of data that will be changed. All right, perfect. So now let's execute everything. We have the data set, all good. So let's do this, starting by importing the libraries. Good. Now importing the dataset. Great. Now splitting the dataset into the training set and the test set. There we go. All right. Now let's print xtrain and see what it looks like. All right. So let's scroll down a bit. All right. So that's xtrain with first the column of the age, the age feature, and second the column of the estimated salary feature. All right. And of course we have 300 observations in this training set. You don't have to count them. But there you go, we have many of them. All right, so now let's print ytrain. It's just to have a look at what we create, this is not compulsory. So that's ytrain with all the purchased decisions on the previous SUVs. 0 means that the customer did not buy any SUV, and 1 means yes, the customer bought a previous SUV. And now xtest, scroll down a bit, right, xtest, so same, it contains 100 observations corresponding to 100 customers, and for each of them their age and their estimated salary. And since xtest is actually supposed to be some new data in production, well, we're actually going to suppose that xtest is actually the set of customers who purchased, yes or no, the new SUV. We're going to pretend that xtest is actually some data when we deploy our model in production so that we can evaluate it on the new observations, meaning on the new customers buying, yes or no, that new SUV. All right, it's more fun if we imagine xtest this way, because it is indeed supposed to be some new observations. And now ytest, let's see. All right, and ytest contains, of course, all the purchased decisions of the customers in this test set, meaning whether or not they bought the new SUV. All right, perfect. So now let's apply feature scaling and let's see how xtrain and xtest are transformed. All right, so let's do this. Let's play, and now let's print xtrain. All right, so now we have some scaled values between, well, -2 and +3. This one is 2.06, -1.7. Anyway, it should be somewhere between -3 and +3. Okay, but now we can clearly see that we have both the two features in the same range. The transformed age and the transformed estimated salary are now indeed in the same range, and that's exactly what we're supposed to get with feature scaling. All right? So now let's scroll down to print X test, and the same, we get the two features age and salary taking values in the same range between somewhere around -3 and +3. So this will improve the training performance of the logistic regression model. Well, for the training set, of course, only for the training set, but then when we will deploy our model to predict whether the customers of the test set bought, yes or no, the new SUV, well, we will have indeed to apply the predict method on these scaled values. Otherwise, the predictions will be nonsense, right? The predict method has to be called on a set of features with the same scale as the one that was applied during the training. Okay? Perfect. So now we can move on to the next exciting step where we build and train our logistic regression model on the training set.